Hello, and I'm sorry about the camera footage being shaky, but this is the 16-bit ALU all warmed up and ready to go. The register that stores the result, this shift register here, I mentioned last time how it works, is cleared, and this one has the first add-end. And one note that this is now the LSB and that's the MSB. I changed the configuration. So most significance towards the right, least significant is towards the left. So this and that one, which is 0, get added together and shifted back into to this one here. This circuit here and this circuit here control the timing. Of course, the timer's in the off state now. Okay, so I have a basic problem here that I did by hand. These are random numbers, and this is 18,103. This is 22,456. 22,465, and this is 48,568. When we add these two together, we get this value. And I actually made these two random numbers and put them into the machine, got this out, then converted them all back to decimal, and proved that it's correct, and it is. So let's look here. So excuse me, a cup of coffee's here. For instance, the first add-end here, 0, 1, 0, 1. So starting from the right, we see that it has 0, 1, 0, 1. And the next 4, 0, 1, 1, 1. So that one there and those 3. And then we have 1, 1, 0, 0. And then we have 0, 0. So we have 1, 1. Then 0, 0, and then we have 0, 0, 0, 1. So as you can see, it's 0, 1, 0, 1, 0, then 3 1s to the end of that one, then 1, 1, 0, 0, and then 3 more zeros, and that 1. This is the first add-end, which, as you can see here, corresponds to this one here. It was entered on these keys right here, these switches, but when it was entered, it's entered with the most significant bit being in this, position right here, and the least significant here. It was the opposite last time. So now what I'm going to do, and again the focus here is spotty, is I am going to tell the machine to run in serial mode. I'm going to reset the carry flip-flop, which is what stores the carry in between the adds, and I am going to then put it in serial mode, and I'm going to shift this into the result register. So as you can see, I did this and it shifted. And so now we have that word again, which is 0, 1, 0, 1, yes, 0, then 1, 1, 1, which is shown, then 1, 1, 0, 0, and then 3 zeros and a 1, which from right to left is correct. Now what we have to do is load the second add-end. This is a little tricky, and so I'm going to just pause for a second here. Maybe I'll try to show you what I do. It's a little bit hard. I only have 2 hands, both of which are required to operate the machine. So I'm going to put this camera up against here so you can see it. Okay, so you can see the switches there, and they have to be entered. So now I'm going to enter the next word, which is 0, 1, 0, 0. Okay, 0, 1, 1, 0. No. Yeah, 0, 1, 1, 0, yes. And then the next one would be 1, 0, 1, 1, 1, 0, 1, 1. And then after that, 0, 1, 1, 1. So we have 0, and then the last 3 are on. And remember, it's entered, so you can see we have it entered here, which is 0100, yes, 0110, yes, 1011, yes, 0111. And it's entered here. We have to make sure these switches are okay. They're a little bit temperamental. But now what I have to do is I switch this machine here back to this one register here. It gets shifted back into parallel mode, as so. And then I load it with this one here. Let me see. So as you can see, the new value gets loaded in, while this one over here remains the same. It's same value. There's 5 in the first 4, and the last is 0001. So now what I have to do is carefully leave this in the down position, and then at the same time, all right, it's back into parallel mode there. So I have to turn it back into parallel mode. So that's back into parallel mode. And so now we have it set up for the addition. And so now I can trigger it and it will add. Right? 3, 2, 1. Okay. So you saw it do the addition. And remember, we have the result calculated by hand here. 1001. So I'm going to leave the pencil here. This is the most significant. And what do we see? 1001. See 1001 from right to left. And then the next is 1110, which would be here. We would have 111. See 1110. So that one's correct too. Then we have 0111. Okay, 0111, and then the last 4 is equal to 8. 1000, 1000. So as you can see, it does compute large sums, and it uses the serial transmission scheme I've used in previous videos. I would like to bring this into class, but it is simply too delicate until I have a frame on which to put it, to move it to class. How it works is this is a full adder, and this is a JK latch or a D latch. It's actually a D latch, and it stores the carry in here as an input for C0 for the next stage, and it's able to sequence the addition through. With this methodology in mind, a large, complicated ALU could be built using one bit of logic at a time and simply sequentially operating on the bits. And as you can see here, this is the problem. 18,103 plus 22,465 is 40,568. And this is it in binary and decimal. I'll now give a demonstration in the next video showing how if you keep adding 1, it counts up, and this proves that it works again. Thank you and all the best.